well, hopefully the microphone's on this time, so I can go ahead and answer question 3. Alright, so to start off, looking at the domain of H, it's important to note that right here, to focus on the domain, we don't want, my laser's not working. Whatever. We don't want the square root of 4 minus x squared minus y squared to give us a negative value, because you can take the square root of a negative value. So we could go ahead and write this inequality here and get, oh yeah, there we go. The square root of 4 minus x squared minus y squared is greater than or equal to 0. Some simple algebra to get this right here. It's going to go ahead and give us the domain that I wrote out down here. So the set of xy values such that x squared plus y squared is less than or equal to 4. Alright, to go on to the range of the function, which is a set of all outputs generated, it's important, again, to note the square root, because 8 is the largest value that can be produced, because the square root is never going to produce a negative value. Subtracting a negative value would be adding. We're never going to be adding to 8, so 8 is going to be the greatest value that we get out of this function. I'm going to come back and talk about the range a little bit later too, because as I went through the next couple steps, found out some more stuff about the range. So for part C, and plotting the level curves and changing z for fixed values, it's important to note right here I kind of changed it from h of x of y to z because I had trouble writing it out and kept writing z, so I'm calling it z. Hopefully that's fine. So I went ahead and changed all these z values and held the z constant at these points. So when z equals 8, went ahead and substituted the 8 in on this side right here, solved it out to get 4 equals x squared plus y squared. Same process here and here. Went ahead and plotted these circles out. It's important to note that it's a circle that we're generating. And yeah, that's one of the questions. Typical level curve is going to be like a circle or a loop. So a couple of important parts right here was that when we put in z equals 6, we got the origin right here. When 0 equals x squared plus y squared, that's only going to be 1 point. Another important part is when z equals 5, we get a radius that doesn't exist right here. Negative 5 equals x squared minus y squared. Radius doesn't exist. That'll be important later. So for the vertical traces, when we go on with changing x for fixed values, start at x equals 0, and got this function, which is an upside down semicircle with a radius of 2. X equals 1. Here's what I got. So I went ahead and plotted those. When x equals 2, it's important to note that I got another time when there's only one value where that word for negative y squared. You can only do that, the square root of that, when y equals 0. Another important thing, when we did x equals negative 1, we squared that, so it ended up looking exactly like when x equals 1. Yes. Okay. Yeah. And then when x equals 3, we got another function that doesn't work out. So for fixed values of y, it looks really similar because it's both minus x squared and minus y squared, so they're going to act the same when we hold one of them constant. So same thing happens, plugged in different values of y, found the function, went ahead and graphed it. Same thing happens, we have our 1 point when y equals 2, and then y equals 3 doesn't work out. So I went ahead and used all the plots. Oh, and it's important to look at the zx plane versus our zy plane and XY plane. Different planes that we're looking at, obviously. So this is the picture I came up with. It's alright, I guess, I don't know. But it looks like an upside down bowl, upside down dome. And yeah, that's the shape that I got. Let's check from the question. Yeah. So it's our little upside down dome that we got, and some important parts are right here, like where this plane happens at z equals 8. The biggest the radius gets is 2, and because of that, z equals 6 is going to be the lowest value that we get, which, going back to our talk about the range, means that we're not going to get any outputs bigger than 8, and we're not going to get any ones smaller than 6. And we can find that that's true because when we go back, when I tried to plug in z equals 5, got a radius that didn't exist. It's because the dome doesn't reach down that far. And that's the same with a lot of those values. That we got stuff that didn't work out. The radius doesn't reach that far. So yeah, that was question 3.